Okay, we're going to talk about eccentricity today, not electricity. Speaking of which, electricity knocked the power out of my house last night. Glad I woke up early this morning so I could be here. But eccentricity, not electricity. And eccentricity is this with ellipses, and it's a little different than with the hyperbola. It's still E with the C divided over A. But with the hyperbola, what's going to happen is this. In the ellipses, the A was always larger, so your numbers was less than 1. But with a hyperbola, because C is larger than A, then it makes sense that E has to be larger than 1 with a hyperbola. So if you get it at E, and you take the C term and divide it by A, you're definitely going to get a number that is definitely larger. So here's what happens, okay? As we get a C that is much bigger than A, we have a much wider spread. E is very, very large, as you can see right here. However, if the A is a little further away and C is closer to A, it's going to be a lot closer to 1, and the narrower the the hyperbola will be. So that's just kind of if it's smaller than 1, we have an ellipse. If it's larger than 1 but close to 1, it's a hyperbola, very similar to this. And if the number is very large, it will look more like the much wider spread for the hyperbola. That's all the eccentricity is. It's just the C divided by the A, and that explains what it means.